This video is part 2 of calculating protons, neutrons and electrons, and this time instead of looking at atoms, we're going to look at ions. Okay, so just a reminder then from last time is that we have very often the question looks like this, which is called nuclide notation. So we always have the symbol, we have the atomic number, and we have the mass number. And if you remember, the atomic number tells us the number of protons and electrons, and the mass number tells us the protons and the neutrons added together. In order to work out the number of protons and electrons, it's just the same as the atomic number, and if we work out the number of neutrons by taking the atomic number away from the mass number, so for example in this one, the protons would be 19, the electrons would be 19. They're both the same as the atomic number, and the neutrons is the mass number, take away the atomic number, so that's 39 take away 19, which is just 20. However, we're now looking at ions, so that's for atoms. We're now looking at ions, and ions are formed when atoms gain or lose electrons, depending on what part of the periodic table they're in. So, for atoms to become ions, we gain or lose electrons. So we're either going to have positive charges or negative charges. If it gains an electron, it will become a negative charge because it's more negative. Remember, electrons are negatively charged, so if we gain them, we're getting more negatives. If we lose an electron, well, that means that we've got more positives, because if you think about atoms, they have the same number of protons and the same number of electrons. That's why they're called neutral. That's why they have no overall charge. They have the same number. However, if we start taking away or adding electrons, then we make it more positive or more negative. So if we look, for example, at the first one over here, potassium. So it's K plus with 19 and 39. Now, I know that it's gaining or losing electrons, so the only one that's really going to be different is E. So my protons is still the same as the number of my atomic number, so that's still 19. And my neutrons is still the difference between the two. But crucially, I've now got a positive charge. I've got one positive charge there. So that tells me that I have lost one electron. So instead of having 19, I must only have 18. If I look at the second example, I've got chlorine 1735 and minus. So my protons, again, same as the atomic number, 17. Neutrons are still the difference between the two, so that's still 18. But my electrons have changed because I'm 1 minus, which means I've gained 1. So instead of being 17, I'm also 18 this time. On to the last example then. So this is S2 minus 16 and 32. So my number of protons is still the same as my atomic number at 16. My neutrons is the difference between the two, the mass number take away the atomic number. Now this just happens to be exactly the same as 16 as well. And then the number of electrons, I'm 2 minus, so I would normally be 16 here, but I have 2 extra minus charges, so I am 18.